Good evening. Welcome to Satellite Showtime. I'm Pat Olson. Satellite Showtime is brought to you by fine corporate sponsors, including Luxor North America and Qualtronics Incorporated. We welcome to our show all people tonight unable to attend the Space STTI show in Nashville that's going on right now. And we also welcome those of you watching our show from Nashville. No doubt, many of you have had questions concerning your home satellite system from your neighbors. Many of these questions undoubtedly center around the great variety of programming you can receive with your home satellite system: movies, news, entertainment, sports, and more. Colleen Torvik is one person with curious neighbors. She hails from Mount Clemens, Michigan, and she called us saying her neighbors were concerned about their cable reception after she installed her satellite dish. We assured her that there was no way her neighbor's TV reception could be affected by her home satellite system. Colleen says she has heard some other far-out statements from neighbors in her suburban community.
But I think the main problem is most people are the fear of the unknown, and that is they don't know what this dish is doing to them. They think maybe it's giving off radar or X-ray beams or something, I think. I mean, it's just, you know, people that are not knowledgeable on certain things, and something strange and new, they're going to be up in arms and give all kinds of feedback.
We assured Colleen the only symptom her neighbors could experience from her dish would be jealousy at the variety of programming Colleen could receive. If you have any similar stories to tell us, you can call us at these numbers: 608-647-4246 or 608-647-8902. This week on Satellite Showtime, we cite an editorial from Chris Schultheis of STV magazine from STV's September issue. In essence, Chris says, if you think you can't make a difference as a home satellite viewer, you are wrong. He asks us to look at what happened with the Coca-Cola Company. Quote, an unrelenting barrage of letters, telephone calls, and press coverage forced the powers that be at Coke to back down and reintroduce old Coke. End quote. Schultheis says the home satellite TV industry can do the same with the 7 programmers that are threatening to scramble. He says we must simply raise our voices and pens in unison. The September issue of STV lists the phone numbers and/or addresses of the programmers that are threatening to scramble. We at Satellite Showtime 2 weeks ago announced 2 phone numbers for the HBO chief executive, Michael Fuchs, and we asked you to call him. And those numbers again are 212-512-1364 for Fuchs' personal line, or 212-512-1000 for HBO's general number, and that is to call HBO Chief Executive Officer Michael Fuchs. And for the numbers of other programmers, you can either check out STV Magazine, the September issue, or call us here at Satellite Showtime and we will give you the numbers. Our phone number this week at Satellite Showtime, 608-647-8902. That's 608-647-8902. Do you remember a survey we did 2 weeks ago for an advocate for the blind? She wanted to know how many blind people have home satellite systems. We didn't have any idea how many people would call, but we received 4 phone calls from people who are blind or know someone who has a home satellite system. We want to thank you for your calls, and they will help Ruth Volrath, who's taking a census of visually impaired people in the hope of bringing an audio program service to them.
Luxor, space-age technology at an affordable price. Satellite receivers, antenna actuators, remote controls, and auxiliary sensors, all by Luxor. Here's a totally integrated satellite television reception system. The Luxor 9550 remote controlled satellite receiver. 24 channels selected, fine-tuned, programmed for automatic recall. 4 different audio systems, built-in RF modulator, automatic polarization, 2-speed scan, video inversion control, AFC defeat, and Dolby noise reduction, and more. The Luxor 9534 antenna actuator, automatic satellite selection by remote control, all at the touch of a button, remarkable ease and accuracy. And the Luxor Mark II, a high-performance block satellite television receiver system, several sets, each having their own independent channel selection at the same time from a single antenna. That's the Mark II. Just a few of the high-performance, technically advanced satellite products from Luxor.
The Trans 10 by Qualtronics. This eye-appealing transparent antenna has passed the stringent test of the McDonnell Douglas Corporation. It's approved for 2-degree spacing. In the words of McDonnell Douglas, the performance of the Trans 10 is equal to or greater than that of other antennas of similar size and construction. Not only does the Trans 10 perform, it's also covered by a 5-year limited warranty, and it's easy to look at. Its baked acrylic thermoset black finish gives it a low luster appeal. Yes, the Trans 10 is also built for strength. The patented rib design assures maximum reflector signal and better retention of panels in high wind areas. Independent tests have indicated that the Trans 10 will withstand wind velocities up to 90 miles per hour. The Trans 10 by Qualtronics, high in performance and strength, UPS shippable anywhere in the United States, an antenna for every season.
Satellite TV Preview is the best thing next to your satellite dish. With all those programs now at your fingertips, you won't want to miss a thing. Satellite Preview lists over 100 transponders in an easy-to-read weekly grid schedule. It has a daily list of movies, specials, and sports, plus a list of sports by event. Call and subscribe now for only $47 for 52 issues and save $31 off the newsstand price. Or call for a free sample copy. Dealers, we also have a special offer for you. Call 800-826-0735. Visa and MasterCard accepted. Satellite TV Preview, the best thing next to television.
Welcome back to Satellite Showtime. Mike Gustafson is the West Coast editor and technical editor for STV Magazine. He's also a special contributor to Satellite Showtime. And let's see what he has this week.
Good evening and welcome to Technical Tips for Nova Video. This time we're going to be talking about how to track your dish or anybody else's dish onto the satellite arc. This can be done for new installations, or most likely it's for an old installation that the wind got to or blew it off, or you suspicion might not be tracking exactly across the orbital arc. So the first thing we should really look into before we start to either track that brand new antenna properly or repair the old one is a couple of major points just to make sure the antenna is going to perform as best as it can. So the first thing let's look into is we want to make sure that you've got the focal point correct. The focal point is measured from the front of the feed horn, that's the round part, is called the waveguide, down to the very center of this dish at this point. So it's a distance from here to that point is the focal point, and that dimension is most likely always found in some sort of literature from the company that sold you that antenna. Also, we're concerned about, is this the right feed horn for this dish? Remember in our previous conversations we talked a little bit about F over D for each particular dish. And we want to make sure that whatever feed horn we have up here is the proper one for the dish we own. In most cases, when you get an antenna or your old antenna you're just repairing, the feed is correct for it, and the feed that comes with the antenna has most likely been decided by the manufacturer as being the one you should have. So you're probably safe there, but you should be aware that there are certain feeds that work best for 0.4 dishes and 0.3 dishes, F over D. Remember, F over D is focal point divided by diameter. So you take this distance here and divide it by the diameter of the dish. So, and this is a 10-foot dish, and this particular focal point is about 39.25 inches, so it works out to be about a 0.31 F over D. Okay, so if we have the focal point correct, and we have the right feed for the F over D of the dish that we're using, then we want to make sure it's centered. So we would measure from this scalar ring, these rings are called the scalar rings, measure from this edge down to the edge of the dish, and do that in all 4 points across the dish. Sometimes it's difficult to get the top. If you do just the bottom 3, the right, the left, and the bottom, you're okay. But once again, measure from this edge to the edge of the dish on both sides, then from this edge down to the bottom, and make sure it's centered. And when I say what's acceptable, I would have to say plus or minus 1/4 of an inch all the way around is probably acceptable for centering. Okay, So if we assume that the focal point is set properly, it's centered, it's the right feed, the LNA is bolted on properly, you want to check that. If it's an old installation and you're concerned why it doesn't work, you might want to take the LNA off the feed and verify there's no water in it and that it's clean inside. Put it back on. The cable looks good. We're all set. The polar rotor is hooked up. Polar rotor cable is hooked up to its cable. We're all set. And the next thing we should do is to try to check out and determine if, in fact, we have our polar offset angle correct. Now, I'm going to flip this antenna around, and then we'll talk about polar offset angle. So hang in there for a second. This is a 10-foot mesh antenna, and it's not exactly light, contrary to the manufacturers likes to tell you. They are a little heavy. So we'll get it up out of the way. Now, first let me explain this. Normally, the dish would be a lot lower to the ground. This is a special mount that I use, and it tends to elevate the dish quite a bit off the ground. Your antenna would be a lot lower, therefore it would be a lot easier to do. But let's get back to what I was talking about, a polar offset angle. The polar offset angle, get my inclinometer out of the way, is an angle. First let me define something. This axis right here is the polar axis of the dish. We have some bearings in this particular design on both ends, and the dish rotates about this axis. This is called the polar axis. For proper tracking of the arc, we have to have the antenna to be looking slightly lower than the polar axis. So what we want to do here is we have, you notice these bolts are threaded, and there's no thread shown here at all. It's tightened up as far as it'll go. But on the top one, you'll notice we're showing a lot of thread. So the whole antenna is kicked down from the polar axis, such that they're not parallel. The polar axis is this way, and the antenna, instead of being parallel to it, is kicked down. That angular distance is called the polar offset angle or declination. Now, what is that all about? Well, the polar offset angle, and I should probably go to a little drawing here that will maybe show that a little bit. The polar offset angle accounts for the fact that we are on this portion of the Earth. The only place where we wouldn't need a polar offset angle would be if we were at the equator. The satellite is out here. It's right above the equator. If we had our installation here, the polar offset angle would not really be necessary because we'd be right at the equator. Therefore, we would be able to track perfectly. As we move anywhere up in this region, we find that in order to properly track, we have to kick the antenna down to see the arc. You can see that if we kept it without an angle, we'd miss the satellite. We kick it down slightly to pick up the satellite. But we still have to have our axis, our polar axis, pointed to true north, the North Star up here someplace. That angle still has to be held true. So we're kind of caught between a rock and a hard spot there, but the way we solve that is called the polar offset angle, where the actual antenna is physically tilted down from the axis itself. Now, let's look at how that angle, we won't go into the math of how the angle is actually computed. Suffice it to say it's a function of your latitude. The further north you are, the more that angle is. The further south you are, the less the angle is. The typical ranges for this go from 4 degrees to about 8 degrees. Here in this area in Northern California, at a 38-degree latitude, we have a polar offset angle of about 6.1 degrees. Nothing too magic about that. So if you're curious if yours is correct, or if you suspicion that you have a tracking problem, then in fact you might want to check it. And there's a simple way to check that. Determine what your polar offset angle should be, and that is usually found in the literature that comes with your antenna, or you may call your antenna manufacturer and they'll probably give you the information. And we're going to compute, this little form I'm going to show you, what this distance should be, how much the antenna should be kicked down in inches. We won't worry about degrees here. So the way we do that is with this little bit of trigonometry. We have a triangle. We have the distance here between our polar axis. All right, so remember, this is the distance between the polar axis, and that means between this bearing and this bearing. That's the distance I'm talking about, distance AB. Okay, AB is the distance between the two bearings where the antenna is physically attached to the polar axis. Okay, the angle X is actually the dimension we want to know. I'm sorry, the dimension X is really what we want to know. We want to know how far should this distance be changed while holding this distance constant. Okay, and then this theta is the angle, our polar offset angle. So it's actually that x distance is equal to the tangent of theta times this distance, AB. Okay, so theta is offset angle, AB is distance between the attached points. So let's do an example for Northern California. Theta is 6 degrees, and I have measured this distance between here and here to be 11.5 inches. These are 11.5 inches apart. Okay, so we have 6, 11.5, so we just plug in the numbers. Take a simple calculator. Tangent of 6 is 0.1051 times 11.5 inches. Comes out to be 1.2 inches. So that means x here is 1.2 inches. Now that's not a total dimension, that is the difference between the two dimensions. Now let me explain that. Let's go back up to the antenna. We already have an offset. You can see we have the distance from here, this point, to this actual axis. So we have to measure that, because that's a constant. Then to it we add 1.2 inches. So we have 1.2 inches from this back of this nut to the center of this axis, plus whatever this is already set to. So in this case it works out to be about 2.5 inches total, because we had 1 inch sitting here. So we have 1 inch set in the bottom part of the axis, and so we have to add 1.2, so it's about 2.2, 2.3 inches offset. Don't worry about being too terribly accurate as long as you're in the ballpark. Remember, the beam width of these antennas is 1.7, 1.5 degrees, so you can be off just slightly, about a little bit with it. Okay, so that's the offset angle, the polar offset angle or declination. That must be set before we can even begin to track the antenna. If that's not set, or you don't have that in your antenna, then tracking it will be virtually impossible. Okay, now let us move on to how to go about actually tracking the arc. There are a couple of ways that can be done with this. One's done with a compass. The other is done with a, where's my compass? Here it is. With setting and finding a local satellite. And first let's talk about doing the compass procedure. I have already indicated that this polar axis has to be pointed to true north. It's going to end up that way once you've tracked this satellite the antenna properly on the satellite arc. So we need to put that on true north. Okay, so a friendly compass will do that. Come around the front of the antenna, and I generally line myself up with the axis. We have to deal with magnetic variation, and magnetic variation is simply the error between magnetic north and true north. And you can find that number out by calling your local airport or maybe another installer, or these kinds of things are found on maps. And it's usually an error of like, and out here it's 16 to 17 degrees. And it's an east number. So if you try to remember something, it's called east is least and west is best. That means if your magnetic variation is an easterly number, you subtract it. And if it's a westerly number, you add it. So in this case, it's in 17 degrees east, so we subtract it, and so we know true north is off in this direction. And we just set this antenna approximately as close as we can get. Now, it's going to be plus or minus 10 degrees. That's good enough. I just don't want you to be off 180 degrees. So if we've got it right within, say, 10, 15 degrees, tracking it's going to be duck soup. Okay, that's using the magnetic compass to get started with. There's another procedure that works just as well. In fact, a lot of people like it because you don't have to deal with the compass. And that is, in almost every location that I have been able to put in dishes around the country, there's generally a satellite that is essentially due south, or very close to due south. So what we want to do is we can actually set our elevation. That would be the next step, and that's the second procedure we're going to show here. And that is we have to deal with how to set this angle. We worried about it in this dimension, in other words, north-south. Now we're going to worry about it up-down. And this is always reference to horizontal. Reference to horizontal. So that means we'll take our inclinometer, it's a $20 item at Sears, and we're going to measure some angle here. Now that angle is the elevation. The elevation is always equal to your latitude. So my latitude here is 38 degrees, so I'm going to look for 38 degrees for my elevation. So I'm going to set this here. Now, you have to be very careful with these little guys because sometimes you have to read them backwards. And the reason for that is it depends on whether you start out here and you count, or you start here and count. Well, remember, I was talking about we want to start out horizontal. So we're going to be, in this particular case, we're going to be counting back from 90. So it's 10, 20, 30. Well, I've got about 39 to 40 degrees. Then the polar offset angle is kicked down just a little bit lower than that. So just to make it interesting, well, anyway, let's not make it interesting just yet. So that's the angle we're going to set. Now, it would be easier to read it if you could actually put it on the axis, but as you can see, this particular design doesn't allow me to get up in here. You can't see it if I do that anyway, but you have to trust me for it. There it says 38 degrees. So here, we're either count backwards, or we subtract 38 from 90, and we're looking at, what, 52 degrees, I guess that is. So we could read it either way, but just make sure you keep it straight which way you're going. So we're looking for 38 degrees. I've got 39 dialed into that already. That's good. That's close enough. Now, given that, if I'm going to do it this way, the second methodology, where I use the inclinometer rather than a compass, we then want to balance the dish. Now, what do I mean by balancing the dish? Well, you want the dish to be perfectly flat on the mount. It's not tilted to the right or to the left. We're going to balance the dish. Okay. Then we're just going to spin it. Now we're going to unloosen the mount a little bit. Almost all the mounts today are pole mounts. They all use 3.5-inch Schedule 40 pipes. They're all about the same. Okay. And what we want to do is, I happen to know in my location that West Star 5 is exactly due south. So I look for West Star 5. But before we go any further, I have to have something to look for a signal on. Well, I have this system wired up already. Here's my cable coming down from my LNA. Let me back up and show you a wonderful little test set that's battery operated, has everything built into it that it needs, has a signal strength meter, a TV set, and a satellite receiver. Has an interesting feature here called scan. And when I throw it into scan, it actually scans all 24 channels for me. I should actually say it scans 37 to 42, and it'll pick up whatever's there. There may not be anything there if you're unlucky. But as you can see, it's scanning right now, and it's picking up some sort of satellite information. So let's just make this a little interesting here. Let's go ahead and spin the dish. We'll just give it a good shove. So we've totally untracked that antenna. And we probably ought to, just to make it even more interesting, let's go ahead and crank it in elevation, out of elevation. You're right, I did count those, but that's okay, you'll have to trust me for it. So we're going to set our elevation first thing. So let's go ahead, I want it. All right. Okay. Turn on the system. As you can see now, it's not picking up anything. So we're going to set our elevation, hopefully properly. And I like to read it directly, so I've got my meter up inside. You might not be able to see it. Okay. Get this set to 38 degrees, my local latitude and therefore elevation. Okay. Check. I'm just checking both numbers. Okay. It's close enough. Now I'm still not getting anything, so we're just going to spin the base a little at a time. And you hear it popping already. And we're should only find one satellite that actually is on our arc at this point. Now there sounds like a satellite. You're not going to be able to see it because of the sun, but try to identify the satellite.
Economical GLC hatchback. Let me take care of business.
Okay. Let's turn that audio down just a little bit. Tune it in. Now we have a signal strength meter here. And we're going to go ahead and just peek up on it. Okay, watch the meter. We're just going to turn elevation. See, there it goes. It's going up a little bit. A little bit more. Ah, we pinned it. Okay, so at that point we can't go any further. Now I have a little adjustment tool here. We'll just turn down our signal strength meter so we can see it. Okay, back on screen. And let's continue our elevation cranking. Okay, looks like that's about all there is. Yep, that's all there is. We're going to put it back up. We're going to peak it. Okay. Now that's out here on a westernmost satellite. So now we're going to go look for something eastern from here. So I put it in the scan. And we're just going to have to listen for this. And I'm going to rotate. There's one satellite, but we're going to get brave. We're going to try to go a little further. Okay, nothing. So we got to go back and take whatever we got for the last satellite. There. There. That's the last satellite we can actually hear. Going east. Turn off the scan. And we take a look. There. We have a signal strength. Now comes the interesting part. And that is we want to set the elevation. We want to note it. We're almost done. So we turn it. Okay, I turned it that way, and then look and see what the dish did. The dish is going up. Signal strength is going up. So we peak it up, and we say, okay, lifting the dish has improved it. And so what we're going to do is peek it up on a western satellite, rotate to the east, and note whether lifting the dish or lowering the dish improves the signal strength. So on the eastern satellite, if moving the antenna up improves signal strength, turn the mount counterclockwise. So that would be this way. So I know lifting it improved it, so let's go ahead and rotate it a little bit. Snug it up just a little bit so it doesn't go anywhere. Then we go back to our western satellite. Scan it. There it is. And then we re-peak elevation. That's it. And then we do it one more time. Throw it into scan. And we come west. All right, come back east again. And we go keep doing this back and forth until we finally get all the errors out of it. There's the satellite. There it is. There's our signal strength. And we know it again. Which way does the meter go? So turning it that way improves the meter, which means I'm still lifting. We found out that moving the antenna up improves signal strength again. So once again we go back on the eastern satellite. If moving the antenna up improves signal strength, turn the mount counterclockwise. So we loosen up our little nut that's here. And we move it just a little bit. And it's real important to not move it too much, because that's a usual problem. People go way too much when they make that adjustment. A little bit each time will do it. Okay, so we'll go put this back to scan. We go back and find our western satellite. There it is. And the arc is getting bigger and bigger as we do this. There's our color bar pattern. So we're going to re-peak up in azimuth and elevation again. Up, looks like we're almost got this one. Okay, no improvement right there. So we're peaked up in azimuth and elevation. throw it back into scan, and that's why a scan is so important on receivers and signal strength meters, is that without a scan and without a signal strength meter, you can go right past satellites and never know it. Or if you're trying to peak this up using just the video, it'd be virtually impossible. Keep coming over and over. Okay, let's see how far we can go with this. There's another one. There's another one. Yeah, okay. As you can see, now that you can't see me anymore, the arc is getting bigger and bigger. So we'll take our scan off, go find a channel. There's an ABC news feed that's getting ready to do its thing. So let's note what happens with our elevation. Okay, I'm turning it, and what's happening? The dish is coming up, and the signal strength is improving. So, okay, we're almost there. So we want to go counterclockwise, just a touch more. So we'll loosen this nut up, and we're going to rotate the last little bit. I'm just sure of it. Okay. Now we'll go back into scan. I'll be very careful with these antennas. They can get away from you. And I've thrown a couple of these like this and had them get completely out of hand and fall on the ground. Okay. There we are. So our Western satellite. That's actually G1 I'm using as my Western satellite. Set that. There's our signal strength. We've peaked in azimuth. Now we'll do elevation. It looks like it wants to come down this time. But it doesn't matter. All we're doing on the Western satellite is just peaking it up. Okay, there it is. All right. I think I went a little too far on that there. All right, I think this is the last time. Put it in a scan. Now we're going to go west. Go west, young man, go west. So keep pulling it over. There's the satellite. Let's see how far we can go with it. There's another satellite. And there's a good, there, that's good. Probably can't even see through the screen mesh anymore, but we'll fake it. There's our signal strength. It's a satellite we hadn't found before. Very, very eastern satellite. Now we're going to note the signal strength. Rotate. Just a little bit. And that's it. So we're almost done. We're almost done. Once again, it was lifting the dish. Yes, it was. So we're going to now just rotate one last time on this guy. It's a little bit. A little bit. Okay. You're wondering, do I have to do this all the time? No, only once, usually in any installation. If the mount was strong and the dish didn't fall off its mount or it hasn't gotten tired, you never have to worry about it. There's our Galaxy 1 satellite again. Back to tune. Note elevation. And you'll find out that the adjustments get closer and closer together. You find out it's just, you're talking a half a turn, a quarter turn. That's it. Very, very close. I can smell this one. This one's almost done. So we bring it all the way back over to our most eastern satellite. Okay, let's peak it up in azimuth because I think we're home free on this one. All right, looking good. Note elevation. No improvement. Rotating it goes down either direction. Okay, that's it. That dish is now tracked. So we will go ahead and put it back up out of the way. Okay. Go back here. And as a final thing, you would snug up the bolts. Make sure they're really tight. Now in this particular case, when I tighten this down, the antenna lifts up just a little bit because of the way the bolt structure, but that's okay. It's only an elevation adjust. It doesn't change the arc. All we would do is one last time peek up the elevation. There it is, done. There'd be no more improvement if we brought the antenna over to the east. It's tracked, it's a 10-foot dish. After you've done it maybe 2 or 3 times, it gets rather simple. The first time, it's going to be just a little bit of time-consuming project, but you'll learn for it and probably benefit the system. So once again, this would be used for an older system that you think has sagged, or the mount is shifted, or the dish has gotten off track, or the brand new installations. So I think that we've used up more than our fair share of time this time, so we'll see you next time. Thank you for joining us. Good night.
Coming up on Satellite Showtime, the Calltronics video newsletter with Joe Kelch.
The Luxor Mark II, a new generation of electronic excellence. The Mark II is a block satellite receiver system. It offers independent channel selection for multiple TV sets from a single antenna. In the home, for neighbors to share, in hotels, apartment, offices, and for licensed SMA TV redistribution to the entire community. The Mark II by Luxor does it all. You receive the best signal, the highest possible performance with Dolby high-fidelity sound. Other features include the individually programmed audio, AFC automatic fine-tuning controls, all on the 24 programmable channels. An infrared handheld remote will give complete control over the channel selection on any satellite. It's all so easy with Luxor Mark II. See it and then enjoy it. The Mark II does it all.
Are you confused about satellite programming guides? Are you tired of monthly inaccurate guides that are big and bulky and about as much fun to use as a city phone book? How about tabloids with hard-to-read print, incomplete movie listings that are about as easy to use as a road map? Or newspaper guides with confusing grids that fall apart in your hands? There is an alternative. Onset, the easy-to-read, easy-to-use weekly programming guide with more movies and sports. Best of all, Onset is only $39. That's right, 52 issues for only $39. But don't take our word for it. We'll send you a free copy of Onset, and you can judge for yourself. And if you're a dealer, ask about our dealer program. Make your customers happy and make money. Call Onset now. Toll-free 1-800-438-2020 or write Onset, Box 2347, Shelby, North Carolina, 28150. Onset, you've seen the rest. Now try the best.
Welcome to the world of satellite TV opportunities, the marketing techniques magazine for satellite television that reviews the latest technology and introduces you to people you should know.
Satellite TV Opportunities is the marketing techniques magazine for satellite TV dealers. Our single purpose is to help dealers increase their sales and their profits through improved marketing techniques.
Call today for your subscription to success, 1-800-922-2812, Satellite TV Opportunities magazine.
Good evening. It's the video newsletter. I'm Joe Kelch for Calltronics. Reminder for you who are in Nashville, welcome to the show tonight. Those of you who couldn't make it, we certainly will be covering much of the Nashville show in the week to come. I'd like to remind you to stop in at the Calltronics booth. There's still a day and a half of the presentation yet, or all day tomorrow, I should say. The staff will be happy to see you at our booths at Nashville. Well, last week we spoke of how to survive in business. And that was Walter Everett's interview in the Satellite Today issue. Well, Walter, who we met last year in a special program that we had in May, is the officer in charge of satellite reception systems of Athens, Ohio. He said a few things that really struck a note. He said that so many people in the industry have to shape up or ship out. Simply this, the distributors, of which Walter is one, and the dealers have got to hone their talents very sharply. He talks about the major market shakeout, which we have had and will continue to have. He spoke of LNAs and dishes and receivers already being reduced in price because of the terrific competition. He says that of the 300 to 400 manufacturers who are and were in the business, he foresees it knocking down to 8 or 12 in a matter of a few short years. These will be people who offer complete systems, 8 to 12 out of the 300 to 400 who now exist. That's a very sobering thought. Doesn't mean that there will be only those, but those will be the major powers to bear. The true distribution philosophy offers certain marketing aids like co-op advertising, technical support, and by all means, field service people have to be out in the field making contacts. Remember that Walter's speaking from the viewpoint of a distributor. He says it is essential to have financial strength. If you have a down month or two and the third strike is by you because you don't have the financial strength, that is a tragedy. You must have production capabilities. They're essential. In other words, you must have a manufacturer who will be able to fill the demand without long delays. We all know what long delays mean: promises, promises, and no more production. And that can lose a lot of sales. Quality products are essential. Now, we all know that, but sometimes we forget it. Adequate features for the price. They don't have to be Cadillacs, but they should have adequate features for the price you're asking. They must be durable, Walter says. Both electronic and mechanical-wise, they must be durable. He says they have to have ease of installation. Quality products invariably are very easy to assemble. Mostly because there's only one focal point, Walter says, not 3 or 4 different ones. He suggests we have at least 3: good, better, best, full-line systems. Good, better, and best. Fewer product lines will help simplify the ordering and your inventorying. Fewer product lines. And by all means, durability is essential. Minimal downtime or servicing will result when you have good, durable products. And dealers look for a distributor who has a good relationship with the manufacturer. If they aren't on good terms, if the distributor blames everything on the manufacturer, you know that there's not a good relationship. Therefore, the distributor, as well as the manufacturer, is in trouble. Also, the distributor should have good service technicians, as all dealers should. But the distributor must have a good line of technicians. On delivery, he says the distributor must have delivery at his fingertips. It could come down to just a few dollars a system if your ordering includes a few systems. In other words, don't try to ship it out with just 1 or 2. If you go in bulk, it's a few dollars and it's worth the effort and the cost to ship. And he says, use road sales people. It's an important contact and it can't be beat. You must have human contact rather than only over the phone. He says, and I think it's so essential, aggressive selling. Dealers who wait to buy the cheapest and then sell price, price, price are losing. They'll be out of business, and many of them are. If that's all you're selling is the lowest price, you're going to be out of business because you have no service department. You have nothing but the price. And people are pretty tired about not getting servicing on a product that they pay much for. But those who really do a job of aggressive selling will find the industry is booming and the sales are really out there. Put money into your servicing. The technical and other long-range items will do best if you put your money into service. And he says finally, we must have a personal touch. 60% of the customers are lost because of bad contact, bad salesmanship, and bad servicing. Let's go over them again. Bad contact, bad servicing, and bad salesmanship. It could be very, very important to remember those three items. That's a synopsis of what Walter Everett had to say in Satellite Today. If you out there have any ideas that you'd like to have us express, put them in a letter, a note, or give us a call. We'll be glad to do it. Isn't it great when somebody says something really nice about you? Well, something really nice has been said about Qualtronics in the most recent issue of STV magazine. In it, Mike Gustafson, an engineer, tested our Trans 10, and the conclusion, after many tests, was this, and I'd like to read from the last paragraph. It would appear that Qualtronics has a good performing mesh antenna to take its place next to their very successful one-piece 10-foot stainless steel antenna. With the simple shipping, assembly, good looks, and good performance, Qualtronics has an excellent antenna on their hands. Based on my test of this product, I can recommend it for your purchase. What could be sweeter? The Trans 10 by Qualtronics, quality, performance, and strength, and all at a highly competitive price. Engineered for maximum durability and reflective surface, also extremely easy to look at. Baked acrylic, thermoset black finish, low luster appeal. A parabolically formed hub, prime steel, and a solid 14.5 inches in diameter. Ribs of superior strength tubular 16-gauge steel encased in polytrans vinyl. Full half-inch unobstructed mesh retaining channels. The patented rib design assures maximum reflector signal and better retention of panels in high wind areas. UPS shippable anywhere in this country. The Trans 10 by Qualtronics. High performance and strength. Tested and approved to withstand wind velocities up to 90 miles an hour and approved for 2-degree spacing by the McDonnell Douglas Corporation. Yes, the Trans 10 with a limited 5-year warranty is your best buy of all mesh antennas on the market. The Trans 10, the antenna for every season. In our studios today, Al Williams of Luxor, and Al's Eastern Region Sales Executive for Luxor. Appreciate your stopping in, Al, and want to have you say a few words about Luxor, about yourself. Let's start with yourself. What's your background?
Joe, I have been with Luxor for a few weeks now. Just recently came on board as part of a change in organization, or an addition actually. Came from a need for an Eastern and a Western distributor sales executive to actually go out and interact with distributors and provide support for all their needs. Previously, I was with another company based out of Atlanta that did a lot of commercial satellite and other type of communications work, and then I had been involved in the satellite industry before then.
You know, it strikes me that we at Qualtronics, who are a distributor for Luxor, and we value a manufacturer like Luxor who comes out and tends the flock, so to speak. Comes out and we see the people that are involved, and you come out on a regular basis, and that we like.
Well, we feel like there's a need there to come out and see our distributors and get some feedback on what their needs are. It's very important for a manufacturer to know what they're doing right and what they're doing wrong, what changes need to be instituted, and that's very important to us, and that's really a part of the biggest part of why we're doing this.
Anything that you can tell us about the upcoming Nashville show as far as Luxor is concerned?
It's going to be a very exciting show for us. We have got some exciting new things coming to the Nashville show. We're going to have somewhat of a new look, and of course it'll be a chance to for distributors and dealers to come by and see all of us, and we want to see all of them also, and take a look at what we've got, and also there will be a chance to meet some of the new personnel on board at Luxor that haven't been there before in previous shows.
I think we have time to go into just briefly some of the background of Luxor itself. We have Luxor North America, which is a part of the Swedish.
Right. There's a parent company in Sweden called Solara Luxor, and they are owned mainly by, mostly 70% owned by a company called Nokia, who last year had $2.5 billion of sales. That's in U.S. dollars.
Billion?
$2.5 billion. That would probably put them in the Fortune 500 here in the United States. So there's a strong background there for Luxor North America, and there's a strong commitment from Sweden to make Luxor work in the United States.
And as far as any new product or products, we'll have to wait for Nashville.
Right.
Okay, we'll keep on anticipating what might be coming. Al, a lot of luck. And good fortune. I know that Luxor is launched on a new expanded role in this country.
That's right.
Thank you very much, Al.
Thank you.
You betcha.
Here's the answer to your satellite cable needs. Calltronics Dual RG6 1500 megahertz sweep tested all-in-one satellite cable. Direct burial, sunlight resistant, and UL approved. Wraparound feature allows for easy entry through walls. Simply peel back wires for different electronic hookup. Meets any and all installation codes. This all-in-one satellite cable from Calltronics. Call for pricing. Quantity discounts available for immediate shipping. Phone 1-800-826-CALL, K-A-U-L, or in Wisconsin, call 1-800-826-NOVA, N-O-V-A. The Trans 10 12-rib design by Calltronics. This beautifully designed and crafted transparent antenna is setting the industry on its ear. With the latest in antenna technology, the Trans 10 12-rib has strength, accuracy, and beauty at a price you won't believe until you experience the quality and savings yourself. Baked acrylic, thermoset black finish, super strength rib, hub, and rim. Calltronics means quality, and the Trans 10 12-rib lives up to the Calltronic tradition.
And that's it for today on our video newsletter. Hope you enjoyed it. See you next week.
Want to know more about satellite TV? Then go to the source. for product reviews and how-tos. We're on the road and out in space, and sometimes in very cold places, with features and technical reports. It's all in satellite TV. That's only $19.95 for 12 big issues of STV magazine. Call now, 1-800-438-2020, and get this LCD calendar clock free with your subscription. That's 12 big issues of STV magazine and the clock for only $19.95. The number again is 1-800-438-2020. 1-800-438-2020. Call now.
That's all for this evening's Satellite Showtime, brought to you by our fine corporate sponsors, including Luxor North America and Coltronics Incorporated. Next week, we have all sorts of treats in store for you from the Space STTI Nashville show. That's next week. Tonight, the news and information continue on another satellite. As a matter of fact, 3 other satellites. You can listen to Keith LaMonica's FM America program on Comstar D4, Transponder 20, SpaceNet 1, Transponder 18, and Telstar 303, Transponder 18. Keith also has his own video program. It's brand new and comes on Sunday nights on the satellites and channels I just mentioned. And don't forget, there's also another program about the home satellite industry. It's Boresight. It comes on Thursday nights at 9 o'clock p.m. Eastern. Satcom 4, Transponder 20. That's all for this evening's Satellite Showtime. Until next week, good night.